size from just a few feet across to hundreds of miles wide. They, like everything else in the solar system, revolve around the Sun. The larger ones are sometimes alternatively known as planetoids. While more than 1 million asteroids in general have been identified so far, according to NASA, some of those have already struck our planet, with impacts of varying severity happening throughout history, while many more are possibly on a path to collide with Earth in the future. First and foremost, it is for this reason, to try and keep across what might or might not happen, that astronomers eagerly study asteroids in the first place. They're keen to learn about their orbits and physical characteristics, and whether or not we should ever be especially concerned about any one asteroid in particular. But despite the danger they pose, opinions aren't all bad regarding these enigmatic space rocks. Although for many decades, scientists believe that asteroid impacts may have hindered the emergence of life on Earth, that view has been set aside more recently, with many now suggesting that crashing asteroids could have instead played a crucial role in the formation of life, by providing deliverables essential for the chemistry of living things. These deliverables may have been in the form of new habitats that an impact crater creates, spawning lakes as well as regions of lower and higher altitude. Or, more significantly still, it's thought that past asteroids may have brought water to the surface of the Earth, probably the most important single substance of all. It's believed that asteroids may have even helped to shape the atmosphere of our world too, sparking and nurturing growth of complex organic molecules within. Impact craters may have also provided some shelter against ultraviolet radiation from the Sun before then as well, while the atmosphere was forming. Asteroid impacts such as the Chicxulub event, which led to the extinction of the dinosaurs, are also known to have helped create hydrothermal vents, which work a little like a plumbing system to help drive Earth's own evolution forward. And contemporary views consider these vents to be of massive importance. Theories are that, over millions of years, they have helped to transport heat and chemicals from our planet's interior to the surface, and in doing so, regulate the chemistry of our oceans. The resulting accumulation of minerals on the sea floor then, again over millions of years, has helped to promote life on our planet and guide the important transition from chemistry to biology. Enter Drs. Rebecca Martin and Mario Livio at the University of Nevada's Department of Physics and Astronomy. In 2022, they released a draft paper titled Asteroids and Life: How Special is the Solar System? Through it, the authors suggest that asteroid impacts on a terrestrial planet may be a necessary condition for life. And then, if asteroids are essential, then asteroid belts might also be just as vital for life to emerge in a star system. While it appears that in ours, the solar system, the belt between Mars and Jupiter will have played a key role, could it be the same in other exoplanetary systems too? These systems beyond our own would then also require similar mechanisms to what we have to drive the asteroids out of the belt and toward any potential habitable worlds, to bombard the surface of planets that lie within the Goldilocks zone of an alien sun, and in doing so potentially seed them with life. This realization has important implications then in our wider search for alien life. The main takeaway is that if we want to find alien life in the universe, we should perhaps begin by looking for stars that specifically host systems with asteroid belts like the one in our own neighborhood. For example, we know that our belt hosts millions of asteroids, so it would make sense to target a similarly well-populated alien belt too. The origin of our belt is tied up with the formation of the solar system itself, as bits of dust and rock that weren't incorporated into the creation of planets settled instead to become the asteroid belt. Again, if the importance of the belt is correct, then we'd perhaps be best served searching for a star system with a similar backstory to our own. The mechanisms to drive asteroids out are a little more difficult to determine, but there are at least two theories, called the Nice model and the Grand Track, to suggest that the regular and periodic influence of giant planets, such as Jupiter and Saturn in our case, is what's crucial. It's thought that the presence and influence of the gas giants has continually disturbed the asteroid belt over time, which is why rocks have fallen out and towards the Sun, occasionally crashing into the inner planets like Earth as they go. Similar disturbances are thought to restore the belt over time too, so that Jupiter and Saturn act something like gatekeepers for the belt, regulating what goes out and what comes in. With this important connection in mind, Martin and Livio, as part of their 2022 study, considered its consequences in 3 separate simulations, each running a different arrangement of giant planets in our solar system with the Earth in its present orbit. Amazingly, the simulations demonstrated that Earth faced the highest number of asteroid impacts in the current configuration of the solar system. One alternative arrangement had one of the giant planets take twice as long to orbit the Sun as the other, which resulted in far more asteroids being ejected from the belt, but with lesser impact events on Earth. Meanwhile, in the other alternative, where the second giant planet was removed completely, impact events on Earth were even further reduced. The finding then seemingly supported the idea that an asteroid belt and wider solar system as close to ours as possible would equal the best bet for alien life elsewhere. To back their simulations, Martin and Livio examined NASA's exoplanet archive, detailing planets beyond the solar system. While some are rogue planets, free-floating worlds that orbit galactic centers rather than a star, most exoplanets we know do circle stars, and many that are much like our Sun. For further research, these were the ones that were of most interest. Digging deeper into the specifics, the authors focused on systems with two known giant planets, and especially when those giant planets were found at similar distances away from their host star as Jupiter and Saturn are from the Sun. This is a challenging task, as exoplanetary detection of massive planets in wide orbits is quite difficult. Among the candidate systems that Martin and Livio identified, 4 of them seemingly had just the right arrangement. That is, an arrangement to support the correct disturbance of asteroids out of the belts and to provide for the emergence of life, according to their hypothesis. In essence, as per their hypothesis, the search for extraterrestrial intelligence had, on the one hand, suddenly gotten a lot harder because it was much more specific, but also, on the other hand, gotten much more nuanced and informed. A habitable world in the habitable zone is perhaps no longer enough. Neither is a sun-like star alone. This work suggests there should also be similar giant planets to those that we have, positioned at similar distances, and that those giants should similarly regulate a comparable asteroid belt to provide all of the earliest events and building blocks for life. That might all feel like a lot to ask, but the authors arrive at a somewhat optimistic conclusion, highlighting that, quote, "The solar system is somewhat special, but the degree of fine-tuning that may be necessary for the emergence of life is not excessive," presumably meaning that, in their view, it could happen again. And now, if we follow this line of thinking, we could be better prepared than ever to find it. That said, and despite these intriguing results, Martin and Livio also concede that the fact that this model is largely based on the classical picture of solar system formation could yet hold it back. The story of creation may not be the same in other solar neighborhoods in space. There could be other events and mechanisms at play that we can't really comprehend. Nevertheless, what are your thoughts on the potential importance of this new way of looking at distant planetary systems? For now, there is of course still so much we don't know about the universe, but that's why alien life could yet be hiding in the asteroid belt, or another asteroid belt elsewhere at least.